Hello there, welcome to math class. We have this question to solve. It says the diagonals of a rhombus are 10.2 cm and 9.3 cm long. Calculate correct to one decimal place the perimeter of the rhombus. How do you find the perimeter of a shape? Let's assume you want to find the perimeter for a triangle. You just have to add up all of the sides together. The three sides, you add them up, and that'll be. And if it's a square, you just add up all of the sides together, or rectangle, you add up all of the sides. That's the perimeter. So for a rhombus, it's like a square anyway, and all of the sides are equal. We have to like turn it, and let's try to construct a kind of similar distinct rhombus. So this is one side of the rhombus. Then I can try to like get one of the sides, you know, copy this to get another side. And I can turn this left to 90 so I can join it at the top here. Let's assume it's perfect. Yeah, even if it's not perfect, I can just manage it like this. Then I can also try to, you know, get this other hand and flip it. It's almost there, so let's see. Yeah, if I get this and I flip it, it's going to give me the other side of the rhombus. So this is the top side of the rhombus. Then this one's going to give me the bottom side. So I just flip this vertically. Then it's going to close up here. There we have a rhombus. All of the sides have to be equal. Now, one of the property of rhombus is that it has diagonals. So the diagonals of the rhombus, they have to meet at right angles. They have to form right angles. So and try to join this again. Yeah, okay. So let's say this is the first diagonal. I can just maybe I change the color of the diagonal to be blue. Then I want the other diagonal to be green. You know, so you can see it's a perfectly straight line. Then if you check the angle between the two diagonals, if you like try to check it out, it's going to meet at 90 degrees. So all of them are going to be 90 all through. So this is 90 degrees. Good. So what do we have to do to get our perimeter? To get the perimeter, we have to add this side, this side, this side, and the other side together. All of the four sides, we have to add them together. But to add all of the four sides together, we need to find the length of one side. So to get the length of one side, we need to know, uh, we can bring out, a right angle triangle to use maybe Pythagoras theorem to be able to find the missing length. So let's firstly fix our diameter, I mean the diagonals. So 10.2, maybe this is the shorter one, 10. Okay, the longer one is 10.2, the shorter one is 9.3. So this is going to be 9.3, while this is going to be 10.2. So for the 10.2, the upper part is going to be 5.1, which is half of 10.2. And for the 9.3, this part alone, which is the half of that 9.3, is going to be something like 4.65. Yeah, I think so. 4.65. So for the triangle here, I have 4.65. Then I have 5.1 for this vertical distance. So I'm looking for this hypotenuse. So with Pythagoras theorem, I can find the hypotenuse if I call it y. So I say y squared, or I call it the length, since it's the length I'm looking for. So I say L squared equal to 5.1 squared plus 4.65 squared. So here now, L is going to be square root of, this result. So let's try to use a calculator and get it. 5.1 all squared is going to give us 26.01. 26.01 plus 4.65 all squared. 4.65 squared. That is 21.6225. So 21.6225. So we're going to add this together and find the square root to get the length. So we got 21.6225 plus 26.01. So we have 47.6325. So square root of 47.6325. So when we get a square root of this, we have to, we'll be able to get a length. and try what we want to do to that. Yeah, let me see again. Okay, I'm trying to get a calculator. Yeah. So um, square root of this is 6.9016 or something and stuff. So that's the one length, 6.9016. You can say 6.9016. So approximately you can use 6.902. Now the parameter we're looking for is the length, 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 and each one is 6.902. So centimeters. Then to get a parameter, it's going to be 4 of that length. That is 4 times 6.902 cm. And finally, the parameter is going to be 6.902 times 4. So that's going to be 27.608. 27.608 cm. And the question says to one decimal place, to one decimal place. So that means we have to stop on this 6 because the next is 0, so it doesn't affect it. So the perimeter finally is going to be 27.6 centimeters. So that is how to solve the first part of the question. Then we still have one more part to look at, which is this one. So, okay, welcome to the second part of the question. The question says, given that sine x equals 3 over 5 and 0 degrees less than x, that means x is greater than 0, then x is less than 90. That means we're dealing with an acute angle, you know, acute angle. Then we can use a SOHCAHTOA, which is sine, cosine, and tangent. So here now, what we're going to do is to try to represent all of the details, given in a right angle triangle. And how can we get that done? You should be familiar with ka, and toa. So that means sine x or sine theta or sine whatever you're given is opposite over hypotenuse O and H. So that is opposite forward slash hypotenuse. Then the second one is cos x or cos theta or cos anything. That's cosine theta equal to adjacent of the shape all over hypotenuse. And the last one is tan, tan theta or tan x or tan p, tan whatever you're given. So that is opposite over adjacent. O and A, opposite and adjacent. So opposite over adjacent. Now, having said that, we need a right angle triangle, something, like this, that we need to identify where our theta should be. In this case, we label it x because it's x we're given in the question as sine x. Now, sine opposite of this x is this line that is facing it here. While the hypotenuse is a line, this is right angle. So the line that is facing right angle, this slanting line, slanted line is that is the hypotenuse. While the other line that join the x, the angle you're considering, the other line that join it with right angle, this line that join with right angle is what is called the adjacent. So in this case, this is our adjacent. This is our opposite. It's facing x, I mean this line here. So if I label it, maybe let me just put some sort of labeling, maybe A, B, and C. So we have three lines, line AB, line BC, and line AC. So line AB is the adjacent. So if you see adjacent in the formula, like this place or this place, we're referring to that line AB. Then opposite is a line that is facing the angle X. So line BC, this is the opposite, while the other line that faces right angle degree, AC, is opposite right angle. That is hypotenuse. So now, from what we're given, we knew sine theta, say implies that sine x equal to 3 over 5. So that means opposite is 3, hypotenuse is 5. So opposite, because sine is opposite by hypotenuse. So the opposite is 3. So this place below here is 3 cm or something, while this hypotenuse is 5 cm or something. So we're going to use Pythagoras theorem to get this. And Pythagoras theorem states that hypotenuse square equal to opposite square plus adjacent square. So that means 5 square equal to 3 square plus the adjacent we don't know. So adjacent square. And adjacent square will be hypotenuse square minus opposite square. And this is 5 square, which is 25. Uh, 3 square is 9. So 25 minus 9 is 16. Then that means a equals the square root of 16 because a squared is 16. So square root of 16. A will be 4 cm. So this place is going to be 4 cm. Now that we have the three sides, then we can highlight the remaining part of this cos x. Cos x is going to be adjacent over hypotenuse. So the adjacent is 4, the hypotenuse is 5. So we have 4 over 5 for that value. Then we need tan x. Tan x is going to be opposite, over adjacent. So the opposite is 3, the adjacent is 4. That's going to be 3 over 4. Now that we have the three, items listed out, then we can approach the question. So we should find this value of 5 cos x minus 4 tan x. So let's do that maybe in a box here. So what the question say is the value, let me break question there. It says find the value of this one, which is, this, the value of this. So 5 cos x. What's our cos x? Cos x is 4 over 5. So that means this is equal to 5 times 4 over 5. Then, 5 cos x. Cos x is 4 over 5. So 5 times this minus 4 tan x. Tan x is what? 3 over 4. That is times 3 over 4. Then we're going to have, them cut themselves out. Like 5 cancel 5 and 4 cancel 4. Then we have 4 minus 3 as the final answer, which is 1. So the value of this is 1. And that is how we do this particular one. So you can subscribe to the channel if you like what you just watched. We're going to meet some other time. So goodbye for now. See you.